What if your ESP32-CAM could not just stream video, but actually understand what it is seeing and call it out in real time? In this video, I am going to show you exactly how to build that. We will connect an ESP32-CAM to a YOLOv3 object detector running on your PC and make it detect people or literally any of the 80 COCO objects in a live video. Here is what we are building. The ESP32-CAM acts as a wireless IP camera, streaming GPG frames over your local Wi-Fi. On the PC side, Python grabs those frames, feeds them in YOLOv3 model running inside OpenCV and draw boxes around everything it detects. Every detected object gets a green bounding box with its class name and confidence score. But our special target, the person class, get a red box, corner accent and a big red alert banner. It is like a tiny DIV security system. For hardware, you just need one thing, an ESP32-CAM module. I am using the AI Thinker version, about $2 to $3. Open the Arduino sketch linked in the description. The only two lines you need to change are your Wi-Fi name and password, right here at the top. Everything else is pre-configured. After uploading the code to the ESP32-CAM, open the serial monitor. You will see your IP address. Copy it. We paste it into Python next. Now open the command prompt and install the two libraries, OpenCV-Python and NumPy. In your project folder, you need detector.py and model folder in which we have three files, coco.name, YOLOv3.config, and YOLOv3 weights. Target class is set to person by default, which means that it will detect the person. If the detected object matches the target, a red line is drawn across it. If it does not match, a green line is drawn across it. So basically the system highlights the important object differently. As you can see, I walk in front of the camera and the ESP32-CAM is detecting me. Since I have set the target as person, you can clearly see a red line appearing across me, which means the system has successfully identified the target object. Now when I show another object like remote, you will notice a green line appears across it. Similarly, when I show a mouse, again a green line appear around it. This is because it is not the target, so the system is marking it differently. This clearly shows how accurately the model is distinguishing between the target and other objects in real time. Now let me open the code and change the target object to remote. As you can see, when I place the remote in front of the camera, a red line appears across it, which means it is now successfully detected as the target object. You can also notice that my hand is being detected as a person, showing how accurately the model is identifying different objects. Now when I show a mouse, since it is not the target, a green line appears around it. And finally, when I walk in front of the camera again, this time instead of a red, a green line appears around me. This clearly proves that the system dynamically updates based on the target. We define it working and amazingly in real time and is working amazingly in real time. And that's how you can build smart target based object detection system using ESP32-CAM and YOLOv3 with Python. As you saw, by simply changing one line in the code, we can switch the target object and the system instantly adopts, highlighting it with a red line while marking all the other objects in green. This makes the project not only powerful but also very flexible for real-world applications like security, monitoring, and automation. If you enjoyed this project, don't forget to hit the like button and subscribe to the channel for more amazing IoT and AI projects. Also, let me know in the comment what you would like to see next. Thanks for watching and see you in the next one.